Welcome students. Today in vectors we'll be discussing section formula. In coordinate geometry in 11th class we did section formula. Now we'll do it for vectors and we have two cases. Section formula for internal division. Suppose we have a line segment joining 2 points A and B. Our aim is to find a position vector of point P which lie in between A and B somewhere, dividing it in the ratio m is to n internally. So we'll write position vector of point P dividing line segment joining 2 points A and B internally in the ratio m is to n is given by OP vector. Position vector of P will be OP vector. It is m times position vector of B. M times position vector of B plus n times position vector of A. क्रॉस करके मल्टीप्लाई करना है. M times position vector of B, n times position vector of A upon m plus n. This is for internal division. Let us discuss why we are getting this. Now let us have a line segment AB. We'll explain this. This P was divided it in the ratio m is to n. Now vector AP and PB are in the same direction and we have AP by PB is m by n, or I can say n times AP is m times PB, and as AP and PB are AP vector and PB vector are in same direction, these are in same direction, and n times AP is m times AP PB, means we can write n times AP vector is m times PB vector. So this implies n times AP vector कैसे लिखेंगे? Position vector of P minus position vector of A. M times PB means position vector of B minus position vector of P. Now we can open these brackets. NOP minus NOA MOB minus MOP. Now we'll get OP वन साइड, OP वेक्टर को एक साइड ले लीजिए, MOP इधर आके MOP प्लस का हो जाएगा प्लस NOP, तो OP M प्लस N and we'll have MOB plus NOA. So finally we can write OP vector is nothing but MOB, M times OB plus N times OA upon M plus N. This is for internal division. Section formula for external division. In external division, what we have in position vector of a point P dividing AB externally in the ratio m is to n is given by m times OB, position vector of POP is m times OB minus n times OA upon m minus n. Now let us discuss its proof. Here we have 2 points A and B, and we are taking the case m is greater than n. R is a point dividing AB in the ratio m part is to n part, m is to n. So this part is n. So we have m by n is AR by BR, or you can say MBR is NAR, and BR and AR are in the same direction as BR and AR are in same direction, कोलिनियर है और सेम डायरेक्शन में है. तो therefore m times BR vector is n times AR vector. So this implies MBR means M position vector of second point R, OR position vector of BOB is N OR position vector of second point minus position vector of first point. So we can simplify MOR minus MOB is NOR minus NOA. Now we can write M minus N into OR vector MOR minus NOR. तो M minus NOR is MOB, MOB इधर चला जाएगा minus NOA. So we will get OR vector, position vector of point of division OR is MOB minus NOA upon M minus N. Now position vector of midpoint of line segment joining A and B is given by OA plus OB by 2. This is very easy to prove. These are 2 points A and B. Say P is the midpoint of AB, then it will divide AB in the ratio 1:1, AP equal to PB. So you can say 1:1 or 2:2. So let it be 1:1. Then position vector of P will be OP is 1 times OB plus 1 times OA upon 1 plus 1, or OP vector, position vector of midpoint is OA plus OB by 2. In the next class, we will be discussing exercise 1 and 2 based on the vectors.